In this lesson, we'll try to cover a lot. This will be quick though, and let's just start with the derivatives of an inverse function. We'll also go derivatives and integrals of exponentials. So let's look at the derivative of an inverse. If y equals x cubed is the function, and then the cubed root of x is the inverse, let's look at the corresponding points on those graphs. Over 2 up 8 for the function, over 8 up 2 for the inverse. The slope at 2 would be the derivative of this, evaluated at 2, and the slope is 12. At this point, we'd have the slope at 8. We take the derivative of this, 1/3 x to the negative 2/3. When we evaluate it at 8, we have 1/12. So we can see this relationship that the slope of an inverse is the reciprocal of the slope of the function, but it's not at the same number. It could be at the same number if it was right here. We'd have the same, be at 1, 1, but every other time this number is going to be different than that number. They have to be corresponding. The x value of the function is going to be the y value of the inverse, and that's how inverses are related. So we end up with this formula, but you just have to remember that this is an x value of the inverse, and it's a y value of the function. This is an x value of the function, or a y value of the inverse. All right, so let's find the derivative of the inverse of f at -3. We know that this is the y value of the function. So we know that we have -3 equals x cubed minus 6x plus 1. Usually the questions like this, you could just guess and check what's going to happen. They're not going to make this, usually, this is not going to be that challenging. So if we just look, there could be a 2. We have 8, 9, 9 minus 12. So x equals 2. If we didn't have an easy way, or we couldn't guess, we'd have to move that over and use synthetic division to find the 0. So now we know the x value is 2 for the y value of -3. So the derivative of the inverse at -3 is 1 over the derivative of the function at 2. And the derivative of the function is 3x squared minus 6. So we have 1 over 3x squared minus 6. And we get 1/6. We have 12 minus 6, so we have 1/6. All right, pause the video and try that one. We know that 2 is a y value of the function. So we could add 14, divide by 2, and the cubed root is 2. So the derivative is 1 over. The derivative of the inverse at 2 is 1 over the derivative of the function at 2. So here's an example where they are the same, but they won't always be the same. F prime is 6x squared. Finding the derivative of that, 6x squared minus 0. So we have 1 over 6 times 2 squared, 1 over 24. And that's all we're going to do for derivatives of inverse functions. Let's go to derivatives of exponentials. All right, and the derivative of e to the x is e to the x, or e to the u is e to the u. So here the derivative, we're going to look at e to the u as the outside function, and then negative x squared as the inside. We need the chain rule. So one way to memorize that is we always copy it. Copy it because the derivative of e to the x is e to the x, so we copy it. Then we do the chain rule, and then ln of the base. If we forgot this step on this problem, it wouldn't matter because that equals 1. But if that base is not e, then we're going to need an ln of whatever the base is. So here we have negative 2x e to the negative x squared. So we just copy, we do the chain rule, and then ln of the base, and that's the derivative. Okay, pause the video and try that one. Copy, chain rule, ln of the base. Here we have 9x squared e to the x cubed. Ln of e is 1, so we'll leave it like that. Okay, if we have a base other than e, we just follow the same steps. Copy, chain, ln base. So here the derivative is copy, chain rule. The derivative of 3x is 3. The derivative of 1 is 0, so we have just 3. And then we need ln of the base. So 3 ln 2 times 2 to the 3x plus 1. Pause the video and try that one. Copy, chain rule, ln of the base, 2x ln 4 times 4 to the x squared. Okay, and we can't forget all of the differentiation rules. And here we have a product. So we have to do the product rule. The derivative is filling in that pattern where we have the first times the derivative of the second. The derivative of the exponential is copy, chain rule, ln of the base. Ln of e is 1, so we're just going to put another 1 there. You have e to the negative x times the derivative of the first. Negative, let's see, why don't we just factor, and we'll have a x e to the negative x. Take out the e to the negative x and an x, and that's what we're left with there. Take out an x e to the negative x, and we're left with a 2 there. And we can rewrite that as x negative x plus 2 over e to the negative x. Oops, that'll be a positive x when we put it in the denominator. All right. Pause the video and try that one. So when we do the derivative, when we do the chain rule, there is a quotient, but we don't need to use the quotient rule. So why don't we rewrite that with a negative exponent, and then we can just do chain rule. So this is not calculus, this is just rewriting. So instead of dividing by t squared, let's multiply by t to the negative 2. Now we just have e to some power, and we'll have the derivative is copy, chain rule, ln of the base. The chain rule gives us 6t to the negative 3. And let's just rewrite that as, and put the 6 here. Let's rewrite this e. We have a negative 3 over t squared. This is in the denominator. ln of e is 1. Since we have a negative exponent, we can put that in the denominator. T cubed e to the 3 over t squared. So let's just throw that one in. We can find the equation of a tangent line. Pause the video and try that. We need to find the slope, and then do the point slope formula. So here we have an exponential. The derivative is copy, chain rule, ln of the base, which is 1. We don't have to worry about simplifying because we're just going to substitute a 2. So put a 2 there and we get negative 4. Put a 2 there and we get 4. 2 there and we get a 4. So it's e to the 0 times 2. So that's 1 times 2. The slope is 2. And then point slope is just 2x minus 2. So y minus y, the y value is 1. X minus x, the x value is 2. And the slope is 2. Add 1. So it started out looking a little complicated, but it got really simple. Okay, let's do antiderivatives of exponentials. So let's rewrite that. E to the negative x, not the negative x, e to the x to the negative 2. X squared is in the denominator there. We're going to move it to the numerator, and it's x to the negative 2. X cubed, substitution. So let's let u equal the exponent. The derivative is negative 2x to the negative 3 dx. And this is negative 2 over x cubed dx. So we have a negative exponent, and that means when we multiplied by the reciprocal, we have x cubed over 2 du is dx. Let's divide by -2, multiply by x cubed, and now we'll be able to substitute for dx. There are no limits, we don't need that, and we'll have e to the u, so u is x to the -2, x cubed dx is negative x cubed over 2 du. So we get to cancel x cubed, and we'll have -1/2. The antiderivative of e to the u is e to the u. And then we just substitute for u, -1/2 e to the x to the -2, and it could also be written as 1 over x squared. Alright, pause the video and try this one. So we don't have to rewrite that. Let's just start with substitution. And we'll let u equal the exponent. Du is -4x cubed dx. Du over -4x cubed equals dx. U replaces -x to the 4th. Let's leave that the way it is. And dx is du over -4x cubed. So here the whole factor cancels, and we just have the integral of e to the u, which is e to the u plus c, e to the -x to the 4th plus c. So when we do an antiderivative, right now when we do an antiderivative of an exponential, we're going to focus on the exponent as being u. And we'll just finish with definite integrals. And we'll start with focusing on the exponent. U is 3 minus x. And then we do the derivative of 3 is 0. The derivative of -x is -1 times dx. So negative du equals dx. U evaluated at 4. U at 4 is 3 minus 4. U at 3 is 3 minus 3. So now we integrate from 0 to -1, e to the u, negative du, substituting for dx, and negative 0 to -1, e to the u du. The antiderivative of e to the u is e to the u. Let's go e to the -1 minus e to the 0. Substitute the -1, substitute the 0, and we have -1 over e plus 1. E to the 0 is 1, negative is a positive. All right, pause the video and try that one. Let's let u equal this, and we can see that the derivative of this is going to be down to an x squared, so that should work out well. U equals 1/2 x cubed. We can write it with a 2 in the denominator like that, or a 1/2 in front. Du is 3/2 x squared dx. Multiply by 3 and subtract 1. Let's isolate dx. I'm going to multiply by the reciprocal of 3/2, so that'll be 2/3, and we'll divide by x squared. Du over x squared. U evaluated at 0, U evaluated at -2. Substitute a 0 right there, and we get 0. And then put in a -2, and we'll have -8 over 2. So this is u, we have e to the u, and then dx is going to be this whole thing. Now we have cancellation like this, with a 2/3. The antiderivative of e to the u is e to the u, evaluated from -4 to 0. E to the 0 minus e to the -4. Substitute the 0, substitute the -4, and we'll have 2/3, 1 minus 1 over e to the 4th, and we can leave it like that. We'll stop there.